Y'all hear that? Hopefully that works. I'm just testing the sound right now. Let me know in the chat if you can hear it. Hello, hello. Audio. Hello, hello. Can you hear it? Hello. Okay, it should work now. Awesome. Yeah, I'm just testing out this new setup for the video. Should be a bit better quality, and then we'll wait for a few people to jump in, and I'll be able to help us review based on that slaughterhouse of a quiz, huh? We'll do better this time. Let us see. All right. Just curious about what you guys see on the screen share. Do you guys see the little green you are sharing screen icon up there, or is it just clean on the screen share? Like on the screen sharing, I'm presuming I'm sharing my screen on Zoom. I hope. Do you guys see the top bar which says like mute, stop video, security, participants, all that stuff, or do you just see the screen up but like cleanly with no Zoom stuff over top of it? Oh, okay. So just the screen. You can't see the you are sharing screen stuff. That's awesome. Okay, perfect. I've got the setup working then. That's very exciting. And my webcam view, I presume, is actually my webcam. Excellent. Took an embarrassingly long time to set that up. All right. So yes, we'll be starting up with this stuff shortly. I wrote out a bit of an agenda for today. I want to know what you guys found to be the hardest on that quiz that was a bit of a slaughterhouse. Kind of don't mention the specific questions maybe because we're technically not allowed to do quiz-related content, but just like what ideas were the hardest. Then I'll be going through kind of the same topics as what was covered on the quiz, but not the same questions because I don't want to like, make it too easy. But I'll be going over like the same ideas, hopefully focusing on the ones that you guys found a bit more difficult, and then going into some of the stuff from the assignment a little bit. Even though the tutorial is going to be mostly assignment stuff. This is just a quiz session mostly. Like if you were to divide it up, this is for quiz content, tutorial is more for assignment content, but both will cover a little bit of both. And hopefully after this, you guys will be able to easily ace whatever they throw at you. Just as long as you ask a lot of questions, you'll be good. So once a few more people join in, we'll be ready to go. We see 13 in right now. We'll see for like a minute or so until anybody gets in. Hopefully you guys are all doing good. In the meantime, if any of you want to hop on the mic or on the chat and tell me about what ideas you think are the hardest. Not necessarily what questions you think are the hardest, because I'm not allowed to cover the exact questions, but if you want to tell me about what ideas you found the hardest, like what concepts, let me know. What are instance variables? Okay, I'll add that to our list of things to cover. If anybody else has any other ideas as to what is difficult like what was hard on the quiz and what was hard in general in the course, maybe what's unclear about the assignment, anything you guys are finding hard at all, you feel free to private message me. I won't name drop you, or public message me and I will name drop you. And abstract, somebody's saying abstract classes. Okay, we'll be covering that. If you want to learn about abstract classes, I did cover them a lot last tutorial, and I will be covering them this tutorial as well. So if you are sticking on for the tutorial, we will be going in depth on the abstract and interfaces during the tutorial. That's going to be like the real core of the tutorial. But to help you guys out with things like abstract classes and inheritance, I will actually be kind of designing a bit of the tutorial in front of you guys live later on in this session. Like I'll actually show you guys how I build it, and that should make it really clear how exactly it works. And then if you stick around for the tutorial, you'll see it implemented. Somebody else is saying overriding methods. That is really related to abstract, so we will be seeing that as well. Yeah, great. And you see, guys, I didn't actually get to ever see the distribution of which questions on the quiz people found the hardest. I only learned like the distribution the same one you guys saw. So I don't actually know what you guys struggled with the most. So I will be covering all of the ideas on it briefly. So I see most of what you guys are asking about is stuff from like later on afterwards, but I will still be at least in the beginning briefly covering like doing a bit of review of the same ideas that were on the quiz. I'll maybe make it fast unless any of you guys really did struggle with it, but I'm sure there's a lot of people who did struggle with it. And I'll be starting that shortly. For our first little thing, we're going to be going into, well, reference types, like passing by reference and all of that in Java. And I know it's a really, like a bit of a tricky topic. There, you guys should be seeing my screen now. It should have just faded in. And you should see a window of IntelliJ with this program. Does everybody see that? Okay, that's fantastic. So, well, when you do things by reference or not by reference in Java, does everybody have like a decent idea what that means in theory? Like, you don't have to understand the exact concept, that's okay. Just like the very basic theory of it. Can anybody give an idea? You're welcome to go on the mic or the chat to give an idea of like the theory. What is reference and what is value? Yeah, that's really solid. I was asking more actually in the context of like the programming, like when you change something by value or you change something by reference. What does it mean to change something by value, and what does it mean to change something by reference? Yeah. Yeah, that's great. And actually, guys, just because I'm a bit of a madman, I'm going to explain this to you in a way that they would probably get mad at me for trying to explain it to you. And it might confuse you all more, but I really think if you bear with me, it might make it a lot more clear. I'm not going to be showing you Java right away. I'm going to show you C++ first, and it's not part of this course. And I promise it's going to be really easy. It's the most basic C++ you've ever seen. But you see, the difference between Java and C++ is in Java, reference types are implied. Like, look at this code I have open here. I can't point to it with my finger because I don't like have the opacity low or whatever, but you can see where my mouse cursor is. Where here does it say I'm passing by reference or value? Nowhere. It's never written, right? All you see is I'm changing something ij, I'm doing whatever, and you can, if you remember the quiz, you'll remember that part of it, you have to read this code, and nothing is explicit. You just have to assume what Java is implying about what's reference and what is value, right? And that's really tricky. It's tricky for me, and I've been doing a lot of Java. And I can only imagine seeing Java for the first time, it must be super tricky to you. But what helped me a lot understanding reference types is the lower level language where you have to explicitly deal with reference. You see, Java is supposed to be making life easier for us. So they hide the reference from us. They make it so it's impossible to see whether something is reference or value unless we really dig into it, like I will over here. But in a lower level language like C++, you actually see, like in the code, where it's reference and where it's value. So here I'm going to transition you guys over to my other screen, and you're going to see what it looks like if we make everything super explicit. Give me a second. Okay, now you guys should be seeing this thing that looks a lot like IntelliJ with a lot of comments. Is everybody seeing that? Okay. So bear with me here. I'm going to explain a bit of code that you will not have to know for the course, but I promise you it's going to make it really easy to understand reference types. All right, first, look at this part, int main. Int main is the same thing as public static void main string args. It's just the main method, same as Java. Nothing scary, all right? Same syntax. And look here, I declare a one-dimensional array. So everybody's kind of following along so far, right? I've got a main, and I declare an array. I know it might be intimidating. We're going into a different language. Don't worry, it's almost identical. I do basically nothing here that's C++ special. So I call a method called display. And now display looks kind of weird. See, I take this m as an argument, this array, and then I do some weird crap. I say std cout something something. All this is doing is it's printing the array. I'm doing system out println array I. You've all done this before. You've all printed an array. I'm just printing an array. It's nothing scary. Nothing is going on here. And then size of is just length. You can see I've commented exactly what everything is. It's just the same as Java, a little bit of a different syntax. So no need to be intimidated there. Now here's the part that's interesting. So do you guys see the void change array up here? All right. So in C or C++, there's a syntax for something called a pointer, which is a reference. And when you put the star next to the pointer, that's what's called or that's like, you're dereferencing. You're saying what is in this reference, I'm changing. It's the same thing that we're doing in Java when we say, like here, I'll transition to my Java screen and I'll show you on Java. If we go into, sorry, I have so many scenes on this bloody OBS, it's hard for me to find them. Okay, so in Java, when I do names ij equals names ij.replace, what I'm doing is I'm saying, you dereference names ij, you take the reference to names ij, you find the value stored inside that reference, and you change it to this. Does everybody kind of understand that? If you don't, no pressure, you can PM me, I won't name drop you. I'll just explain it in more detail if you guys are struggling with that. But basically oh, by all means, sure. So I'll just give a quick recap for you since you just came in. I'm showing you guys C++ versus Java, and it's not C++ is not in this course. Don't be intimidated. It's nothing to do with this. The reason I'm showing you C++ is because C++ shows you reference types explicitly, and Java has it implied. Like if you're familiar with Python, you'll know that Java has like types that are explicit, and Python has types that are implied. So in Java you write string args, in Python you would just write args because it's not explicit. Similarly, in C++, it's even more explicit. In Java, reference types are implicit. You don't actually see the reference types. It just shows you like the name of the variable. In C++, it's explicit. You have to put little stars and ands to deal with reference types. So I'm showing you guys kind of similar code between C++ and Java to explain to you where reference types take place. Now here, names is an array, and I'm accessing it by reference, because arrays or objects, so anything that has an association with an object, that's a .java file or a .class file, is passed by reference. And here, I am modifying the reference to names by accessing, I'm accessing the reference, I'm reading from the reference to get a value, I'm saying the value stored inside names ij is going to be replaced, if it's like a j, I'm going to replace it with an s, and then I'm going to put it back into the reference names ij. Now hopefully that's kind of clear. If I show you guys the same thing now, it's going to be a lot easier to understand if you see it in C++. But transition over to here, I'm going to replace, this part is a bit different because I'm accessing the array without using an index. So an array, the first pointer to an array is the top of the array. So if you know how an array works, it's storing a bunch of values as like a list of references. So you have like, let's say a memory address 1, you have the first item of the array. Memory address 2 is the second item of the array. It goes on like that. It's the same in Java, same in C++. You'll just never see it in Java because it's hidden from you. But in C++, I'm accessing the first element of the array by just saying a star, which means the value stored at this reference of the array, and I'm changing it to 5. And if you see I run this program, it'll start off with an array that says 1, 1, 2, 3, 5, 13, 21. And then after I run the code, it changes it to 5, 6, 2, 3, something. And it's the same reference. You see, in Java, I would just do a system out print line the array. And I wouldn't show you what I'm printing. But here, you can actually tell. I am printing the very same array. I just display array, change array, display array. So I never change the reference. It's always, the array is actually always the same value. In fact, I can actually print out the exact reference of the array. I can show you what number, like in the RAM, the array actually is. So I can say std count. Why does not let me do it right now? Why is it not letting me do a cout right now? Bruh. Oh, that's because I forgot the second semicolon. Silly. Alright, so if I run this again, you can actually see the exact value. So this array is stored at memory address 0x. This is just a hexadecimal number. There's literally a number, like an integer, that shows you where in your system's RAM, like your actual computer's physical memory, this array is stored. And then when I go into this and I say, I'm going to access this array, and notice how change array doesn't take an array's input, it takes a reference to the array, we call it pointer. Then I dereference it, I get the value out of the pointer, and I change it to 5. And then that literally goes into the memory address. You can see the value of PTR is going to be this hexadecimal number. It goes into my computer's RAM, it changes the value, and it doesn't affect anything else that touches it. And then when I do +1, it just affects the thing in the next element of RAM. So that's the explicitness of the pointers. Like you literally have a reference type, which is a number, which points to a specific place in your memory. And then when you modify it, you dereference it, you change it, and then you put it back. And now the C++, hopefully you guys kind of follow along with it. It's okay if you don't completely understand. It's a complicated topic. It's just kind of like a basic showing that there is literally just a number that corresponds to where in your memory this thing is, and you're changing it. Now, can anybody think of when in C++, given this kind of syntax, you might have a situation where it's no longer passed by reference? It's okay, it's like a hard question, so if people can't come up with it, I'll try to make it easier for you. But if anybody wants to challenge themselves, try to come up with a situation where in this C++ context, it will not be passed by reference. Or if something is unclear, by all means, I'm just experimenting with showing you guys this method. It might be way over everyone's heads, and that would just be my fault. I would be introducing you to a new language to explain a simple concept. Who knows? Maybe it's not a great idea, but we'll see. If anybody does want to give a guess at it, then it'll hopefully help us understand the Java part. Then doesn't int x equals 5 have a place in the memory as well? Yeah, int x equals 5 does have a place in the memory, but its place in the memory is stored in a different part of the memory. Sorry, could you explain what does not pass by reference mean? Well, passing by value and passing by reference are two slightly different things. So passing by reference means you're literally passing the number that corresponds to where in your RAM something is stored. And passing by value means you're passing the actual number itself. But the only things that can actually be passed by value are primitive types. And you'll know that it's a primitive type in Java if I transition my Java screen. You'll know it's a primitive type in Java because it'll have a lowercase letter in its type declaration. So here we have Boolean. Let's just say b equals true. That's a primitive type because it's got, first of all, it's highlighted in orange, and second of all, it's a lowercase name. Now Boolean, b equals true, is a reference type. Or I guess Boolean bow is a reference type. So that's how you know it's a primitive or a non-primitive. And primitives can be passed by value because they're values that are simple enough that your computer can literally pass them like between its different components. Whereas an object is more complicated, and it actually requires the system to like do some logic to be able to process it. So it passes around a primitive as well, and the primitive it passes around is the reference to where it's stored in the memory. And you can see that implicitly in Java, or in C++, you can see it explicitly. Because what it does is, when you have to pass something more complicated than like an int, you have to use the star notation, and you have to dereference it. And when you pass something primitive, like an int, you don't have to do that. You're just passing the value straight up. Hopefully that's clear. If that's not, please let me know, and I will try to re-explain it a bit more, in more detail. But essentially, when you pass by value, you can only pass certain very simple things. When you pass by value, you're passing a number, a simple number. Everything you pass by value is a number, and every reference you pass is a number. And you can see that where I print out the memory address in C. It's passing a number. The only things that can be passed are these numbers. Anytime you pass anything more complicated than a number, you are just passing a number, which is a reference. And in a language where it's explicit, like in C, you literally type, I'm passing an int, and the int is a star, which represents that it's a pointer. It's a reference type. And then when you pass this reference type, you have to deal with it like a reference type. In Java, you never say you're passing an int. In Java, here, you would actually write something like void change array, int input. Or you'd say something like void change array object input. And these are the same thing. That's the trick of it. So in Java, when you write, void change array, and then you have an object like a reference type as your input, it will pass the reference, just like C++ or C. It passes an int. Except in C, you actually write that you pass an int, and that int is the reference. And in Java, you're not writing that you pass an int. You're writing that you pass an object, because that's more readable, and it's more easy when you're programming to say, oh, I'm passing an object, and I know what kind of object I'm passing, and it's so much easier to understand in one context. But then when they hit you with the quiz questions that are like, oh, when is it being passed by reference? When is it being passed by value? Then it's going to be hard in Java, because it's all implicit. It's designed to hide that from you. It's like designed to hide the complexities of the language from the users. And because it's designed to hide it, you'll never actually get to see when you're passing these values, like you are in C++. And okay, that's all the C for today. If that confused you guys, sorry. Don't mean to to bring you a whole new language to explain this concept, but hopefully the ones who did understand it really well now. And I see somebody has their hand raised. You're welcome to talk, and you're also just welcome to interrupt me if you'd like. Yeah. Yeah. I can't answer that question in explicit detail just because I'm not allowed to. We're doing a redo, so I can't give you specific quiz-related information. So what I'm going to do is I'm going to answer a slightly different question that will hopefully shed some insight on what you were asking. And sorry I can't answer it more explicitly. I'm just simply not allowed to. What I can tell you is that when you're changing an array, you should keep track of like how you actually change it. You can see here I've put in my Java code. It's on Java right now, right? You guys can see my Java screen, or is it on my C screen right now? Okay, it's on my C screen. Okay, it's back on Java now. So you see here I've got a two-dimensional array. Kind of harkens back to what you guys have seen before. And here I am altering the array by accessing index ij, and I'm replacing stuff. And if you run this code, I have it print out the memory address of the array here in the bottom, and you can see the memory address remains the same because I'm just altering what's in the array. But you have to be careful of what the syntax is, and think about, if you understand it well enough, you can think about the C++ version of it, and think about when you're creating something new, when you're creating a new reference, and think about when you're using a reference that already exists. You create a reference by declaring a variable, like string names here. Right? This is creating a reference to names. You can have more than one reference to names. You have to have at least one reference, and this is the reference. That should not have happened. Come on, go back to normal. There. So I have this reference to names here. Now notice that in this code, I never change what's in names. I never change the reference to names. I changed the values inside of names, because remember, what's stored in an array when you access it in index ij is a value. What is stored in the value names is a reference. So names is the reference. Names ij is the value. I'm changing names ij because I'm changing the value here, but the reference is staying the same. However, if instead of that I wrote names equals new array, or I guess new, it's not how you declare it, new string 10, and then like that, that is actually changing the value, or not the value, that's changing the reference. Stupid question, but is a 2D array int or int? A 2D array is the one with the two boxes afterwards, because it has two of them. The two boxes refer to the two dimensions. So here you can see when I'm changing the value inside, and the value inside means I'm actually accessing each index, and it's getting me the value. Then I'm changing the value, but I'm leaving the reference the same. When I'm changing the reference by using this, I'm changing the actual memory address it's pointing to. So if I run this code now, it's going to throw a null pointer except. No, it's not. It's just going to say null. But you can see the memory address has changed. Just to be sure, one particular array is one object of class array. Well, an array is not strictly an object of class array because I don't believe that it's implemented in the same way as a class is in Java. An array is something more primitive than that. It's kind of halfway between a primitive and a real like object type. But yeah, you get the point. An array is one specific object of an array type. Yes. And you can see, so you guys look how the memory address changed when I did names equals new string 10 whatever, right? But the memory address did not change when I accessed the value inside of the array. So quick shorthand, quick trick for you guys that will help you guys maybe understand it intuitively better. If you're accessing the index of an array, it's a value. If you're accessing just the name of the array without putting the boxes, it's a reference. Hopefully that little rule of thumb will help you. And when it's a 2D array, you're actually, and you're accessing the first of a 2D array. So if I'm accessing names I, it's actually both a value and a reference, if that makes sense. So names I is a value in the sense that it is an integer that points to a memory address. Like in C++, remember, a reference is int, it's just an int. So names I is also just an int, that it's being stored as a value. That's a value. But that int is not just any other int. it's actually also the memory address of the second array that's inside of that array. And yeah, it seems confusing when I say it's both a reference and a value type. But if you think about the C++ and you think that a reference type is nothing but a value type that is being used for a special purpose, it's nothing but an integer that points to a specific part of your memory, then you can see that what it makes sense. That the first index, so I, of a two-dimensional array, is a value type. It is the value of the number of where in your memory it is located. But also it is a reference type, because that number corresponds to another array. Kind of hopefully makes sense to you guys. I would write you guys a two-dimensional array thing in C++ to show you explicitly, but I think that you'd probably get lost in it because it's a completely different language. But if you guys are interested in that, like, let me know, I could. But probably not today. Hopefully that makes it a bit more clear. Quick questions. Strings are also reference types, but since they're immutable, changing the value would change the reference, right? Well, depends on how you change it. So strings are a reference type because strings are an object. There is someone somewhere a long time ago sat down on their computer, and just like you guys are writing .java files for your assignment, they sat there and wrote string.java. They created an object. And since it's an object, it's not a primitive, it's passed by reference. However, if you change it, are you changing the reference? That really depends on how you end up changing the string. You can't change a string directly and not change the reference usually, but you could also do it by reference. Like you could wrap a string in a size 1 array and then have a reference to a string. Or you could, since it's immutable, you can't actually go back and change it, but you could also probably play around with the variable declarations and make it in such a way that you would be able to change it. It's a tricky situation. But yeah, strings are reference types. In C++, int stores a reference, and in Java, int stores a value. Well, okay. That's a bit of a complexity that maybe that's one of the reasons that people don't normally start teaching C++ halfway through a Java course. But the short of it is this. An int in C++ is just an int, and an int is Java is just an int. They're both values. In C++ and in Java, they use ints to store memory addresses. That's every programming language. Every computer has memory that you can access with an int. If you go low enough level, like if you're really good with your command prompt, you could probably just tell your computer to read out whatever is in the area of memory you want by just typing in an int and be like, what is in memory address 5,652? And it'll just tell you. Like, they're all ints in every programming language. It's just Java hides these ints from you. They still exist. If you dig into Java and you dig into the JVM, you'll see that it's just doing the same thing as C++. Except Java is hiding it from you because instead of saying an int with a star next to it as a pointer, it's passing that int, but it's hiding it from you and saying it's actually a string because it's doing all that conversion and all of the dereferencing for you. Whereas in C++, it's just you explicitly write out that you pass an int. Both, on some really low level, are passing integers around. But in Java, it's hidden from you to make it easier. And in C++, it's not hidden from you. That's the only difference. They both store value types. In Java, an int is always a value type. Whereas in C++, an int can also be can be used as a reference. But it's not exactly an int, it's an int with a star next to it, which is like a slightly different thing. It's just syntax to prove that it's a reference type. But for the context of this course, to just get us back grounded, I'll repeat what I said earlier about the two-dimensional array example. A two-dimensional array, when you access its first element, so if I type names I, that is a reference to an array. But a reference is nothing but a value. A reference is just a value with a special use. An example of this could be like a number. A phone number is a number. It's nothing but just a bunch of digits, right? But a phone number has a special purpose that you can use it to contact a person. So when I tell you a phone number, all I'm doing is I'm giving you a bunch of digits, right? I could be like, 55555, that's like a phone number. Or like 911, that's a phone number. But all I said to you was 3 digits. When I tell you there is a phone number and it's called 911, I'm telling you that there is just a primitive type, a number. 911 would just be an int. But that int holds the reference to something else, like a police station. So when you call 911, you're not just having an int with no meaning. You're having an int that's just a simple number that points to something. In Java, they hide this from you. So imagine in Java, it's like you have all your contacts saved on your phone. And instead of typing 911 to call them, you just say, okay, Google, call the police. You know, that kind of thing. And if somebody has a Google Home, I'm sorry. But you get the point. Like in Java, you can type, it's basically giving you one level of abstraction higher. In Java, your instruction to the JVM would be like call the police. And in C++, you'd basically be dialing 911 manually. Does that analogy kind of make sense to you guys? All right, awesome. So yeah, that's a bit of an explanation that's probably above the pay grade of Comp 250, but it's good for you guys because it hopefully makes you understand more of the nitty-gritty of why this works the way it does. And hopefully you guys are all clear on this. If not, feel free to ask away. Otherwise, I'm going to be moving on to our next discussion point, and that's going to be object-oriented programming. It's another big part of this quiz, and it's actually what I got a lot of questions from you guys at the start. So excuse me, I'm going to scroll up to the top of the... can I discuss modifiers in detail? I will discuss modifiers in detail as part of object-oriented programming. I'm just going to make a quick list of the things you sent me in the chat, and I'm going to send it back to the chat to make sure that this is what we need. So we've got what are instance variables, abstract, overriding methods, and then scrolling way back down, we've got can you discuss modifiers in detail? And that's what I'll be discussing next, and I'll just got one more question. What about char? Is it a primitive type that stores the value of char? And in C++, char stores a reference to a char in Java. Okay, so a char is nothing but an int. You guys remember if you did like the 2 uppercase, 2 lowercase exercises, right? Well, when you do those exercises, you find out that a char is just an int. It's just a special int. All the char is your computer has a map of integers to letters. So like, you know, the letter A might be something like 49. And it's actually passed by value because it's just passing an integer. That's why it's a primitive type. Just like a Boolean is passing a 0 or a 1. A char is passing, you know, 67 for the letter A, 52 for the letter B. And when you say char, all that's saying is that your computer knows that you're supposed to map it from a number to a letter. That should make sense for you for char. That's why it's primitive. Anything in Java with a lowercase name is a primitive. Unless you have a really bad naming convention on your own classes. Anything built into Java that's following convention, if it's got a lowercase name, it is a primitive type. And any primitive type can really just be expressed as a number. So if I look through the primitive types, we've got char, and we've got short, we've got long, we've got int, we've got float, we've got double. All of these are just numbers. All right, that will be, I think, a wrap on my quick thing on reference types, primitive types, all of that. If you guys have any more questions, you are welcome to come to my, these are my office hours. You're welcome to post on Piazza, and I'll discuss it in the next office hours. You're welcome to come to my tutorial and ask there. But just because we don't have enough time maybe to go more detail on this, I'll go on to these topics. And that was not meant to be a private message. This was meant to be a public message. Let me just send that to everyone. So these are the topics I'll be covering shortly in my object-oriented programming review. Let us go. I'm going to go to a different project in IntelliJ now. Hopefully you all see it. And this is actually my tutorial project. So if you guys were in my last tutorial, you'll have seen this before. But it's okay. We're not touching the tutorial content. We're actually going to be doing something else right now. So I'm going to propose to you guys a problem, and you guys are going to help me with the solution. I have to program. I'm going to create a new package for this, just so that we don't get confused. It's going to be called, FAQ package. All right. So I need to create a group of related items. I'm trying to make a Minecraft ripoff, and I want to have like weapons, tools, and all that stuff have some properties that are shared and some properties which are unique to each one. So how do you guys think I could best do that? All right, we've got silence. Oh, no, we don't. Go ahead. All right, that's great, a superclass. So we can try that. Let's create a class for, let's call it, I'm not going to do every kind of item, I'm just going to do a tool. So we'll create a new Java class called tool. All right, and let's say the tool has methods like, or it has, let's say, an int durability, int mining speed, int, or I guess like, not image, I'll call it like a byte image, all of these fields, right? Now, how do you guys think it would be best for me to implement methods that are vary between tools? So I have certain methods that are common, right? So I would have like, get durability. And IntelliJ even writes that for me because it's so simple. I could have a, a get image. I could have a set durability. So these methods are common. And then there could be other common methods, like, you know, public int mine, and then object block. I don't know how exactly this would be implemented, but you get the point. Like, all of these should be able to mine and stuff, right? So how do you think I can make methods that will differ between tools? Let's say, for example, we have different kinds of weapons, and you attack things differently with all these different kind of weapons. How could I make a method that is implemented in all of tools? So every tool has to have an attack method, but only some types of tools which inherit from tool will have like attack methods defined in particular ways. If you kind of get what I'm saying. Yes, overriding, that's great. But there's a problem with this, right? So let's say I make this. I say public int attack. I've got a question saying, shouldn't it be this.image? I'm guessing it's here. Not this.image. Well, why not this.image? Because the point of the fields is that the reason we use this specifically is when we have two things of a conflicting name. So if I had a local variable here called image, so if I had like an int image here, and then return image, you can see it gets a red highlight because it actually doesn't know which image I'm pointing to. Am I talking about this image or this one? And in that context, I have to say this.image. And then that tells it that I mean the field image. However, if I don't have a local variable of the same name, image is just, there's only one option for what image could be. So I can just say image. Hopefully that's clear. All right. So let's say we have an attack method, and the attack method needs to be implemented differently depending on what kind of weapon it is. Now there's a problem. The problem is that I've already implemented the attack method. So how do we force people to override it and make it different between every single inheritor? Okay, Benjamin says abstract. Can somebody explain to me why abstract could be better in this context? You know, maybe before we actually get to that, I'm going to create a new class. I'm going to have one called sword, which extends tool. Tool is capital. And I'm going to have a class called pickaxe, which extends tool. And I'm going to have a new one called game. And this is just going to be to hold my main method. And I can say alright, so I've got my main method here, and I've got these things. So why would I want to make an abstract class? That's the core question, and I don't expect you guys to be able to answer it right now, but I'm going to make it hopefully clear with one simple line of code that will make you understand why abstract classes are better. What if I try to say, does that make any sense? Do you think it's logical to have a tool of an unknown type? Like, imagine you're playing Minecraft or you're playing a game. If you guys are not familiar with Minecraft, you can have a variety of tools. But imagine you just have tool. Like, what is tool? Like, am I holding tool when I hold this item? I don't know. Am I holding tool when I hold this? I mean, yeah, I'm holding tool when I hold these things. But for this context of a game, there's no such thing as holding every possible tool. I can't just hold, like, the sum of all tools in my hands. There has to be something concrete there. And because by the definition of the reason we have the tool class, it's just to have like an idea of things that are common between every tool. And I can't like physically hold all the common aspects of tools in my hands. Like I can't physically hold what it means to be a tool, because that's just an abstract idea. And that's where the abstract class comes in. It doesn't make any sense in real life to say like, I'm holding tool, because I'm not holding tool. I'm holding like a handle and a hair comb. I'm not holding tool, because it's impossible to hold tool. And that's where abstract comes in. It's because programming is just, object-oriented programming is just supposed to be like an analogy for things you see in life. Because it's designed to make programs that model things in life. And when you model something in life, there's sometimes these abstract ideas that just don't have a physical representation. And that's the point of abstract classes. Does that explanation make sense to everyone? Or should I say it a bit differently? Yeah, all right. So, yeah, tool is abstract. And abstract gives us certain rules, just like it does in real life. So if I add the word abstract here, and I remove the implementation of attack, now, oh yeah, public abstract. All right, now I made one abstract method. Now, it's actually going to tell me here in my IDE that it's wrong, and tool can't be instantiated because it's abstract. And that makes sense because it's just like real life. In real life, I can't say that I'm holding tool. I can say I'm holding a handle, or a sword, or a pickaxe, but I can't hold the idea of what it means to be a tool in my hands. And that's why it's different. So that comes into the inheritors of tool and how they work. What it means to inherit tool is it means that this is everything that a tool is. It takes all the properties of tool, get passed to it. But it's also responsible for telling you what's different between it and the idea of a tool. I'm going to give you another real life example. This handle. This handle is a tool. It has all the properties of a tool. It has somewhere to grab it maybe. It has a function. It has all these things. But it also has things that it does differently. Like it has this little attachment point where you can attach things to it. It has it has this grip. It's colored black. It has all these things that are not common between it and other tools. Like if I compare it to this bottle of hand sanitizer, these are both tools, but they're different tools because they have a different purpose. But they have things that are common in between them. So what you say when you extend an abstract class is you're saying this has all the properties of a tool, but it implements those properties differently from other tools. So this has all the properties of a tool. It has a physical representation. It has like a physical shape. It has a purpose. It has all these things. And this is also a tool, but they both accomplish the task of being a tool differently. So when something general, a tool, it can be made abstract so that there's more specific versions with quality of the general, but also their own? Yes, exactly. Because some qualities of a tool are useful. Like if I'm making a program that makes a list of tools, maybe I don't care what kind of tool it is. Maybe I just want to list the name of the tool and where it's located in the world, right? And every tool has a name and a location, so why not just generify it to be a tool? Every tool has a place. So if I'm making a program that is to make like a tool board, then every tool on the tool board has its location, it has its name, and they can all just be treated generically as tools because we don't care about their exact purpose. But when I'm out on like a mine, digging for ore, I care a lot about what exact tool I'm using because I'm actually using it for its function. So again, if I'm a miner and I have a pickaxe, an axe, a shovel, a flashlight, if I'm taking inventory of what tools I brought with me, if I just want to know I brought like 10 tools with me, I don't care what tool I have. I just care that it's a tool because it has a physical property and a name. But if I'm actually going to go down to the mines and do some work, I care what tool I'm using. So that's kind of the point of an abstract class. Now, somebody's asking, why can't we have an object of type tool, or can we have an object of type tool? We can have an object of type tool, but it has to implement methods. So if that kind of makes sense, think about real life. The answer to that question is as simple as your own intuition. In real life, you have a tool. Can I have the idea of a tool in my hand? I can't. So there can't be an object of type tool. But I can have an object of type tool because I can have tools. I can have things that have the properties of a tool, but they have to have a physical representation. I can't hold in my hands the sum of all tools, but I can hold in my hands an example of a tool. Hopefully that makes sense. If it doesn't, let me know. If it does, also let me know. I can hold a tool in my hand. I cannot hold the sum of all tools in my hand. So I can't have an object of type tool, but I can have an example of an object of type tool. All right, so let's see. Why is this red? Can anybody guess why my pickaxe class is not letting me not existing? Why is IntelliJ yelling at me about my pickaxe class? Actually, that's not why. You can have a class with no constructor. Can somebody give another try? Actually, yeah, I've got an answer from Test. Test says it doesn't have an abstract method for attack. That's correct. When you create an abstract method, like I have in Tool, you have to implement it. And similarly to how in real life, the idea of a tool has no physical representation. So to hold a tool, you have to implement, the things which are not implemented, like the physical shape. The difference between the idea of what a tool is and a physical tool is that the physical tool has additional properties that are implemented. You know that every tool in existence has to have a physical interpretation. But the abstract idea of a tool doesn't have this physical interpretation. It has an abstract idea. Like the idea of a tool has, for example, an abstract idea for what it means to be a tool, but it doesn't have it implemented. So if we go back into these and we accept the suggestion, it says implement methods. That's right. So we have to actually do the things we define as abstract. And that creates the override. And that is how we create a tool. We can only create a tool when we implement the abstract methods. in the lectures, it was possible to assign a variable to a field of an abstract class. Why is that? The reason that you can assign a variable to a field of an abstract class is that an abstract class is like a skeleton of a class. So let's give an example of a tool, the idea of a tool having a field. Every tool has, let's say, whether or not it's made of metal. Or no, that's not a good field because that's specific. Let's see a general thing about tools. Every tool has a name, so let's call it a field name. And that can have a default value. You can just call it, assign a value to a field. Yeah, so you can assign a value to it. Let's say that the very concept of tool in our heads, like the abstract concept, has a property called name. And if we don't have any other name for it, we can just call it a tool, right? So we can say that there's a string, which is the name, and the default value of that string is tool. And every tool that inherits from it can override it, it can change that value. But just by default, why not have the name of every tool be name instead, or tool instead of null? It just makes more sense, right? Like, if the idea in our head of a tool doesn't say the name is null. The idea in our head of a tool says it's called a tool unless we call it something else. Does that kind of make sense? It has like a string with a default value that we think about. Like this is, every tool is called tool unless we call it something else. It's not null, it's tool. That's why it's a field with a value that already exists. So you can have these fields in the abstract class, and they can have their meanings. It's just you have to think about which ones are implemented specifically and which ones are implemented generally. Is add override an IntelliJ comment? Yes, add override is generated by IntelliJ. Anytime you override, IntelliJ will put add override on the top to remind you that the method is overriding. That's just a little quality of life detail in IntelliJ. It doesn't do that in Eclipse. It's just so if you're writing in IntelliJ, it keeps track of where things are overridden, and it also helps you with documentation. So abstract class can be looked at like a set of default values for a set of specific objects. Default values means something else in programming. You'll find often in programming that programmers are super pedantic about what exact words they use. And you'll find that, sometimes really computer science people are going to get mad at you for saying things like default values when you talk about abstract classes because they have a different meaning. But yeah, the idea you have is correct. It's just default values mean something else. So the way I would put it would be to say an abstract class is like a framework for a class. It's like you build up as much as you can that's true between all of the different inheritors, and then you leave the specifics to the specific inheritor. So for example, for a tool, you could create like this abstract class, which goes over like, it has a physical representation, it has a name, which is defaulting to tool, it has a size, it has a weight, it has all these things that every tool has. And then when you go to the specific tool, you can add the specific details. Hopefully that kind of makes sense. It's like it's a framework for what a tool could be. Yeah, I see a question. That's the trick. We don't have to override everything. No, okay, so I've got sword and I've got pickaxe, right? The only thing I'm overriding is the abstract method. Notice, tool has what, like 5 different methods? We can actually see them in structure. So tool's got all these different methods. It's got like what, 8 of them? Or not 8 of them, it's got 5 of them. But sword and pickaxe only have 1. The only method I need to override is the one I declare as abstract. Because these things are all the things that are common between every tool. And these things are what's specific between the tools. So it saves us time because it lets us only override the things we need to override. Does that kind of make sense? Okay, perfect. So can I explain static versus non-static? I can get to that in a second. I'll just finish with this kind of thing. So here, you see, the tool is highlighted red. I can't create the idea of tool because I can't grab the idea of what it means to be a tool. So what is it doing when I click this? Can anybody understand what's going on my screen right now? Because it kind of throws a spanner in the works from what I was saying before. I'm creating a tool without actually creating a sword or a pickaxe. It's okay if your guess is wrong. I'll explain properly, or I can just tell you straight up if you'd like as well. But if somebody wants to give it a shot, I welcome you. All right, I'll take that as a no. So this is actually also implementing a tool. It's called an anonymous class because I'm not actually creating a tool. I'm creating my own other tool class that only exists in the context of this definition. Notice how I still have to override the method. Here, I'm doing it's called an anonymous class. It's the same as writing sword or pickaxe, but I'm only declaring the class in the context of this one use. And you'll see this in the class a lot. You'll see this if you're doing a graphical user interface where you have to do like an on-click method. You often have to override abstract classes in line with your code. Because what if you only need a tool for the context of this one little line of code? Only on line 5 of main will you ever need this tool. And therefore, you can create it in line. You can implement your abstract class in your declaration. It's just a little detail, but I know this confuses a lot of people when you see it. You might not have seen it yet, but better you see it now and have me explain it than you see it and have no clue what's going on. This is an anonymous class. What it is doing is it's creating creating an inheritor of tool that only exists within this context. So it's actually creating a whole new kind of object, a kind of object which has no name. That's why it's anonymous. But it's just creating a new class of tool right there. And that's just a little detail for you guys to remember if you ever see it. Though you're not going to see it that often. But it is there, and so it doesn't confuse you later. That's there. Is it still a tool? Yeah, it is. I'm creating a tool. Basically, this is equivalent to this. Like if I go into here, having this anonymous class declaration is the same as declaring a class that extends tool. It's the exact same thing. It's just that this class has no name, and it only exists for this line. It's a little trick in Java. It's not really within the analogy. Well, it is within the analogy of what we're doing, but it's kind of just creating it only within this instance. It's a really small detail. Don't let it confuse you about the rest of it. It is still a tool. It's just something that if you do see it, don't be afraid. It's just you're just creating a class only within the context of that declaration. Now, if I want to make this code work, I can say tool t equals new sword. Bam. Now it actually works. There's no red line because the tool is the idea. Sword is a tool. I'm creating a new tool, and it's a sword. It kind of makes sense. I can also say sword t equals new sword because sword is a sword, but I can't say pickaxe t is a new sword. That won't work. Hopefully that makes a bit of sense for you guys. And now I'm going to show you guys something I'll be showing in more detail in the tutorial, but I'll just give you guys a quick showing of it. If I go into, where is it? Diagrams, show diagram, Java class diagrams, build it. Now you can see sword and pickaxe both inherit from tool. And if I go to, where's show methods? Methods. So you can actually see exactly what's happening here. So tool has all of these different methods, and pickaxe and sword just override attack. Everybody see that and kind of understand? Can we do this in Eclipse as well? I don't think there's any way to do this in Eclipse, sorry. There's a plugin you can get for Eclipse to allow you to do this, but it's called Umpel. You don't need it though. It's complicated to use, not very good. If you want to try this out, I recommend just install IntelliJ and try it there. Or maybe there's an online tool. I just use the IntelliJ version. It's really simple to use, unlike the plugin in Eclipse. Yeah, sorry about that. It's one of those things that only exists in IntelliJ. Or exists in Eclipse, but is harder to use. Anyways, so you can see here, on my screen at least, I'll even make it bigger. Fit content. Didn't make it bigger, I thought it would. Anyways, you can see the tool has these methods: get durability, get image, set durability, mine, attack. But attack is abstract. It's denoted by these gray lines next to the method icon. And then pickaxe and sword just implement attack. So the reason we create an abstract class is that all of these methods, all these four methods here, from get durability to mine, are all implemented in tool because every tool does that the same way. But the abstract method attack is implemented by the inheritors of tool. Does that kind of make sense to everyone? All right, perfect. Now, I'm running out of time for the FAQ office hours right now, so I won't go into more detail on abstract classes or interfaces, but if you stick around for the tutorial, which is starting right after this, wait a minute, I'm not running out of time. It's 3:22. I thought it ended at 3:30. It actually ends at 4. I have plenty of time. Sorry about that. I completely forgot what time it ended at. So I actually have 30 minutes. Never mind, we're good. Without tool being abstract, would it be possible to access the method getDurability, for example? Yes, it would. If tool was a non-abstract class, you could still access all the methods. It's just a normal class. Everything about the class tool is normal. It's just a class. The only thing about this class is that certain properties of it have to be instantiated by its inheritors. Does that kind of make sense? Hopefully that makes sense. If that doesn't, feel free to come on the mic or send a more detailed question to the chat and I can try to answer. Do you recommend creating a new package/project for the assignment? Yeah, I do. I recommend working in separate projects for all of your different assignments. The reason for that is that, sometimes, let's say you created a class of the same name in a different, in the same package that you did for something different. It's going to be hard to keep track of. The way I like to do it is I like to create a new project and I like to put it on GitHub as a private repository and track my changes, but you don't have to. If attack wasn't abstract, would the tool class still be abstract? Yes. What makes the tool class abstract is the fact that it's written here. That's the only thing that makes it abstract. It's just the fact that abstract is written in the title, like the title definition of the class. That's all that it means to be abstract. The abstract method is just taking advantage of the fact that it's abstract. But it would still be abstract as long as this is written here. Okay, anybody got any more questions about abstract classes? I'll be happy to answer. Yeah, go ahead. Yes, that's correct. If you ever want to create a tool, you have to define attack. Yeah, of course. Now, if the attack lesson... Okay, if anybody else has any questions about abstract, I'll be happy to answer them. If not, we can move on to interfaces, and I can try to explain those. Okay, go ahead. You can access them if they're in a different project. It's called a library. So if you ever imported a library in Java, that's what it's doing is it's importing a different project, and then you can access its public members. So yeah, if I don't know if we don't see libraries in this course, but if you see libraries, even in here, you can see on my IntelliJ, I've got external libraries. I just have my JDK, which is like, my Java development kit. It's got its libraries. All of these are just public things that from different projects. You can dig into here, see the packages. Java, there's so many of them. Yeah, these are all just classes that are in a public, public classes in a different project. No, they did not. This is, it's 2:30 to 4 on these days, Thursdays. I don't have, oh, does it? What does it say for mine? Oh, I don't know. That's actually probably why I was confused, because I'm pretty sure it's still to 4. It might have just been changed, like, accidentally or something. The way I understand it is 2:30 to 4. If it's not that anymore, I'll have to ask who changed it, because it's a public document. Maybe it was changed for a good reason. Maybe I changed it at 3 a.m. and forgot. I don't remember. Point is, it's supposed to be 2:30 to 4. I see somebody else turned on their mic. Yeah. Sorry, can you repeat? Okay, cool. I don't know. I'll double check on that, guys, and I'll make sure it's correct. It should be 2:30 to 4. I confused myself about that, and I thought it was ending in like 4 minutes, so I tried to wrap it up there. Sorry about that. That was a mistake. All right. What if I create a tool lamp that I don't want to have an abstract attack method for? Do I create an abstract attack method in the lamp class? I'm assuming that this is in the context of Minecraft, where you can attack things with any object. So with a lamp, the attack would probably be like, you just slam somebody with a lamp over and over again, and that's how you'd implement it. I mean, I know it's not programming-y, but like technically if I had a lamp, let's say that this hand sanitizer is a lamp, I could whack you with it, and that would be an attack method. So technically I'm attacking you with a lamp. That's just because in the context of the analogy I was doing with Minecraft, you can attack you can attack using any kind of item, but the way you attack is different. Like, with a sword, you like slash with them. With a pickaxe, you just slam them. With with a lamp, you can slam them with the lamp. With I don't know. You can be creative about how you're going to attack people with things, but you get the point. Hopefully, if you want to create a tool without an attack, so a lamp is a tool. I want to inherit the tool stuff, but I don't want to implement lamp and attack. Okay, then you probably want to define the abstract classes differently. In the context of you wanting a tool which you cannot attack with, then what you'd probably want to do is you want to not have the abstract class tool, or you want to get rid of the abstract method attack here, right? And you want to create like another class, and we can call it weapon. Public abstract class weapon implements tool, and here we could have a, what does it want? Extends tool, yeah. Public in attack. What's wrong with this? Oh yeah, abstract. All right, and now we don't have the attack method here. We have pickaxe. Instead of extending tool, it'll be extend weapon. And then yeah, we can bring in a lamp as well. Yeah, why am I screwing it up? Weapon. And we can make it like a really complicated web of different types of things here if we wanted to. I can also say here we can have a lamp, which extends tool. And now if we go back to our view, this graph view, you can actually see here that tool doesn't have an attack method. Weapons have to be able to attack. So sword and pickaxe are weapons. And then lamp is a tool, but since it's not a weapon, it doesn't have to have an attack method. Does that kind of make it a bit more clear for everyone? Okay, perfect. Now I'm going to throw a bit of a spanner in the works once again. And I'm going to say, what if we want there to be something that can apply to a tool or a weapon or an unrelated object? Some sort of procedure. Let's say I want to be able to dispose of any kind of object. I want to say it's disposable. I can delete it. It's deletable. How do you think I could make every kind of object, so a weapon, a lamp, a tool, or something completely unrelated, deletable? Deletable means it's, you're able to delete the thing. It has nothing to do with what the object's purpose is. Like you can delete a game, you can delete a tool. Every single one of those will implement it differently. But how do you think we can make a delete method available for all these different kinds of objects? Final method in the superclass. Create a superclass above tool. Okay, you guys are kind of on something with the superclass, but are you sure that's the most elegant way to do it? Because in Java, everything already inherits from object. But if we make a chain of these things, let's say like, we have object, then we have deletable object, then we have some other kind of object, and we just have so many things inherit from each other, it's kind of messy. Now, what if we want to make something that doesn't implement that option? Like, what if there's something you can't delete? Then it's hard to implement that. Like, maybe you guys can see if everything, let's say that we make a class called deletable object, and we say everything in our project inherits from deletable object. What if you want to make something that you can't delete? Then how are you gonna, you still have to, you could do it, it's just it would be hard. For purposes like this, there's actually a more elegant solution. And that solution is called an interface. Now, I'll briefly go over the difference between an interface and an abstract class by saying that in an abstract class, things can be abstract, but they don't have to be. Whereas an interface, everything has to be abstract. An interface is like an abstract class on steroids. It's like you have an abstract class, but it has absolutely no relation, not no relation, it has absolutely no implementations at all. It's an abstract class which only has definitions of what should be in it. It doesn't tell you how to do it. Does that kind of make sense? It's like super abstract. It has to be abstract, whereas an abstract class can be abstract. So if you think about it like a triplet, you've got a class must not be abstract. A class can have nothing abstract. An abstract class can be abstract or it can not be abstract. And an interface has to be abstract. Kind of? Somewhat following along with that, I hope. Let me know. Yeah, okay. So yes. Class, zero abstract. Absolutely nothing abstract in a class. It has to be implemented. Abstract class, there can be abstract stuff, there can be implemented stuff. Up to you. Interface, absolutely nothing can be implemented. Now, what's the benefit of an interface? There's a few. First off, you can only extend one class. You cannot extend tool, you can't say like extends weapon, comma, object. It doesn't work. You can't extend multiple classes. You can only extend one class. That's a problem. Because what if you want it to be a tool and you want it to be deletable? You can't make, what if not every tool is deletable? What if you can only delete a weapon but you can't delete, let's say a sword. Or you can't delete a tool, but you can delete a weapon. In that situation, making every tool deletable is not desirable. So that's why we have the interface. So let's try it. I'll make an interface called deletable. And, sorry, what was the solution to the question? The solution was to create an interface. And then I went on to explain in more detail what an interface is. So let's call it deletable. And it's going to have a method, public void delete. Right? So we have a method deletable that we need to have, let's say, only for weapons and not for tools. Well, in here we can write implements deletable. And then in the subclasses of it, we then have to implement the methods. See how this is the same as it was from an abstract class? So if we look at our flow here, where's our graph? I'm going to go back to it if I can find it. Now we can see that the delete method is passed on from this interface to weapon, and then it's passed on from weapon, so it needs to be implemented in sword and pickaxe. So if I fix sword, and I add the delete method, and if I fix pickaxe and I add the delete method, you can actually see that because deletable is an interface, and it has a method called delete, I must implement delete in pickaxe and sword. And because weapon is abstract, and it has the abstract method attack, I must implement attack in pickaxe and sword. But let's say you can also delete a game. And we'll include the method. Now we can see in our graph that unrelated objects can have this interface. Notice how, even though a game has absolutely nothing to do with a weapon, they both can have a delete method. And that's where the interface comes in. It comes from this. Whereas sword and pickaxe get their methods from tool, they get their methods from weapon, but they also get delete from deletable. Does that kind of make sense to everyone? If not, I will be happy to re-explain in a way that's maybe slower and more clear. By all means. Okay. So abstract class is like a framework for a class. It's there, like in tool, to tell you what is common between every tool. It's like, again, it's the idea of what it means to be a tool. Then we can actually specifically implement it. We can make a lamp, which is a tool that you cannot attack with, and you can make a weapon, which is a tool that can attack. But again, the idea of a weapon is a tool that can attack, but you can't just hold weapon. I can't hold the idea of weapon in my hand, so it's abstract. And then you have sword and pickaxe, which are, they can be used as a weapon, so they extend weapon, and they are tools that are a weapon. And they actually have the specific methods implemented. Then I threw a spanner in the works, and I said that, let's say you should be able to delete a weapon or a game, but you should not be able to delete a lamp or a tool. So how can we make it so that there's a common delete method between objects that are unrelated? Because a game has nothing to do with a weapon. They have like no relation to each other. So how can I make it so that we can guarantee that a method will be available in game and weapon, and yet make it so that that method is abstract and common between them, even though they're unrelated? To solve this problem, I used an interface, and the interface was called deletable. And this interface brings the delete method into game and into weapon. And then the delete method is forced to be implemented by everything that inherits it. So deletable forces everything that inherits from deletable to have a delete method. Does that kind of make sense? Okay, great. Can you show the code for deletable? There's no code. It just says there's an interface called deletable, and it must contain a method called delete. So this is saying there is an interface, and here it says every must have a delete method. See, that's all it is. It's just kind of an interface is just like a list of things that should be implemented. It's saying like to be deletable, you have to have a delete method, and that might seem a little bit confusing as to why it's useful now. But let's think about it like this. Let's say we have a really big program and we have lots of different things we have to be able to delete. and I don't want to think about what different kinds of objects they are. Let's say I want to be able to delete games, and I want to be able to delete pickaxes, I want to be able to delete swords, I want to be able to delete tools, and I don't care what it is. I just want to delete all of it. And I don't care what kind of object it is. I don't care what its function is. I just want to delete it. The functionality of deleting has nothing to do with the functionality of a tool or a weapon or a game. It is a completely different function that's unrelated. For that reason, I use an interface. And I say, for example, in game, object, deletable. Right, we have got an array of deletables. And I can say for deletable D in items. Okay, so you can see deletable D. I'll even declare it. I'll say, and I'll make it 3 long. And I'll say new pickaxe, new game, new sword. So these items are all unrelated to each other. What is wrong with this? Yeah. Why is it not like that? I don't know. Oh, that's why. Okay, so I've got this array of deletables, and I don't actually have to think about what kind of deletable they are. All I have to do is iterate through, and I have to tell it it's a deletable, and I can delete it. And here, I'm deleting a sword, I'm deleting a game, I'm deleting a pickaxe. I don't care what it is. It implements deletable, I can delete it. Does that kind of make sense to everyone, why that could be useful? All right, great. I know it's a complicated idea, so it's harder to digest maybe than what you've seen before. So if you have any questions, please ask away. I will be happy to answer them. But before I do, I'll just quickly gloss over the fact that when you look at an interface, you can also have static methods. Because remember, when something is static, it doesn't matter what object inherits it. It'll act the same no matter what object contains that method. Right? So you can run a static method without declaring an object. You can run a static method from an object. No matter where you run it from, a static method is going to run the same. It doesn't matter what object it's coming from. So logically, it doesn't matter what interface, like what here inherits deletable, right? It has nothing to do with it. Like nobody cares what inherits deletable. If you have a static method, it's going to be static either way. So here I can still do public static int, let's say get number 5. Now the number 5 doesn't depend on who inherits it, so I can stay here, return 5. And now I have a method with a body in an interface. Again, it might be confusing for me to show you this now. The reason I can have it is because it's a static method. So no matter what interface, like what uses this interface, like a tool, a weapon, a game, no matter what, get number 5 returns the number 5. It doesn't matter where 5 comes from. 5 will be the same no matter what you're calling this method from. You can call it from a weapon, you can call it from a game, you could call it from a pickaxe. 5 is still 5, so the method acts the same. Therefore, it is static. Therefore, you can declare it in a interface. Now, if that makes sense, I can explain anything more. Please let me know if there's anything I should elaborate on more. Does that only work for interface? That works everywhere. Static methods exist everywhere. I can put, let's say, into a weapon, I could have a static method that's called get pi, and then it returns pi. And then I could have, like in tool, I could have a method called, a static method called get e, and it returns 2, right? So these methods exist. They're static, and they can exist in any class. In fact, the main method is a static method. But the reason I'm specifically talking about it with interfaces is because you can't have a method with a body unless it's static in an interface. Notice, if I try to do public, let's say public short get pi, and I try to implement it here, and I say like return 3. Right? It doesn't work because it doesn't even declare. Like it can't function because I can't have a body of a method that exists in an interface. Does that kind of make sense? Like I can't have a non-static method in an interface. And the reason for that is an interface, it has to be abstract. Again, class, not abstract. Abstract class, partially abstract. Interface, 100% abstract. You can't have anything declared in an interface. It has to be 100% abstract. It's not an object. You have to implement everything. It's totally abstract. There's nothing not abstract about an interface. Yep. Perfect. So that's interfaces, abstract classes, and you can't have anything non-static in an interface. You can't have the body of anything non-static in an interface. Again, I have a non-static method here, delete, but it has to be abstract. It can't have an implementation. I just have to say there exists a method called delete, and here this is like, you know, doesn't matter context. 5 is 5, so it's static. Right, so I cannot have anything non-static with a body. I can have non-static things, but only say that they exist. I can't define them. Does that make sense? All right, perfect. One little other detail about interfaces is you can have what's called a default method. It's actually a new feature of Java. This wasn't a thing before. It's a thing now. It's a bit of a quality of life thing. You will never see this in Comp 250. It's just so that you get the complete picture. You can still have a public default int, let's say get number. And then here, this is not static, it's default. Default means that it's gonna implement it like this normally, and otherwise it's gonna change. Like you are recommended to override it, but you don't have to. This kind of makes the explanation I gave you guys less clear because it actually like doubles up the functionality of an abstract class and an interface. Ignore it; it doesn't matter. The explanation that I gave you guys is kind of like the theoretical explanation as to how it should work. In practice, you could actually probably just not have anything like an abstract class and use default, or you could not have anything like an interface and make everything in an interface, you can make everything a default method in an interface, or you can make an abstract class where everything is abstract, and they're kind of the same thing. So that's what default is, but again, for the sake of my explanation, to give you guys an idea of the theory about what these things should be, interface, 100% abstract. Class, 100% not abstract. Abstract class, in the middle. You can have abstract, you can have not abstract. It's that simple. And then, of course, Java makes it more complicated by throwing in the default in interfaces, but hopefully that default keyword makes it clear to you that that's different from having a defined class. All right, is there anything else anybody has any wonders about? Can you cover final? Yeah, I can cover final. Final is real simple. All final is telling you is that like this number is defined at compile time. You know that it's not going to change. So I could say in game, let's say final int pi is equal to 3. Right, and now I can't say pi equals 4. Well, actually that's in a for loop. That's stupid. But let's say here. It doesn't let me do that because pi is final. So pi can only be defined at compile time. Pi cannot be defined at runtime. A final class is the same thing. A final class, it just means that the value of it cannot be changed after it's created. Like once you run the program, the value of it will stay the same. You can't change it. Final means it's final. It means that you cannot change it after you write it. So here, notice I created a final int pi equals 3. I can't change it to 4 now because I said it's final. Final means it's final. You can never change its value. Is there any reason somebody would create an abstract class with no abstract methods? Yeah, you could. The reason you might want to create an abstract class with no abstract methods is that you think later on you might want to add some abstract methods, or you want to make it clear to everybody that this abstract class is not supposed to be used on its own. Like, you want to make it clear to people who are using your code that this class has no function itself and it needs to be implemented. But realistically, in that situation, you're almost certain to have abstract methods. So, like, you could probably come up with a reason to make an abstract class with no abstract methods. But it's going to be really niche, and it's going to be like, I don't think, you could probably go your whole life and never do it. But it's like, there could potentially be a reason for it. What does it mean for a class to be final? I think I covered that. Can you go over the differences between static and non-static? Sure. So static means that it doesn't matter which object you call it on, it's still going to work. So I could say, you say game.main, right? And then I just say new string. Zero. Now here I'm calling the static method main from game. Actually, main might confuse you guys because main is like a different thing. So I'm just going to call it public static void static method. I'm static. And now I'm going to say public void non-static method. Not static. I have to do with object. Okay. Now, the reason I'm saying I am static and I'm not static, I have to do with object plus this, is I'm saying that a non-static method can access this because it exists in an instance, and a static method does not. So if I say game.static method, it'll run. And give it, come on, run, you bastard. All right, it's run, and it says I'm static. But I can't say non-static method. It doesn't even exist. It doesn't let me type it. Because it doesn't exist in the context of an undeclared game. This depends on which specific game it is. So if I say, you know, game, tennis, new game, and I do tennis dot non-static method, that works. So if I run this, it says, I'm static, I'm not static, I have to do with object, and this is the reference for the game object. And the reason that one is static and one is not is that in the non-static method, I have to be able to access the instance of the game. So I have to be able to say this is associated with this game. Like, the non-static method depends on values that exist only in the context of a game that is an instance. So here, tennis is an instance of game. And when I have a non-static method inside of tennis, it has to do with this specific instance of game. It doesn't have to do with, you know, the idea of what it means to be a game. It has to do with a specific game called tennis. So that's why it's non-static. And the static one can just be called from an undeclared game because it doesn't change. Like, it doesn't use anything that's a specific value of an instance. It uses only what is common between all of them. Does that kind of make sense to everyone? I hope. And then if you go a step further, you can access a static one in an instance. So tennis.static method. Come on, static method. That works too. It's saying it's stupid to do that because I can just say game.static method, but still, it's the same. So I can say, you can say game.static method. You can say tennis.non-static method, or you can say tennis.static method. But what you cannot do is you can't say game.non-static method. Does that make sense? All right, perfect. The person who asked the question. Okay, perfect. So hopefully that makes static and non-static very clear. Static is able to access nothing except for what is static. Whereas if it's not static, it's able to access things that have to do with which instance of the object it's being called on. So non-static is called on a specific instance of an object, and it has to do with that instance. And static has to do only with like the generic of the object. Okay, well, if anybody has any last minute questions, you're welcome to ask them. Can I ask a question about the code in the Sicilian? Why does pizza class have an empty constructor written in it? Isn't this constructor created automatically, or is it empty? Yeah, we can look at that. I don't actually know which one you're talking about. In the Sicilian, why does pizza class have an empty construct written in it? It doesn't. If I have it open on here. Maybe you have an old version of the code. It's possible. Because I had old versions posted from like before. This is the latest version as of the tutorial on... Is the tutorial the same as Monday's? It's similar content, but Monday's was unclear to some people because, you know, I just didn't plan it out as well, didn't have it tested in front of a class. So it's going to be a bit more concise than Monday's, and it's also going to be more related to the assignment because the assignment came out, so I'm going to be angling it more towards things you'll see in the assignment. But the actual content is about the same, so if you completely understood Mondays, you won't be missing anything if you don't come to Thursdays. All right. So yeah, the pizza class does not have an empty constructor in it. It's just you probably have an old version of the code from last week. The latest version has this. All right. If there's any more questions, I can answer those. If not, I'm going to hop into the other Zoom meeting for the tutorial, and I'll see you guys later. Thank you for rolling up. I'll give you guys a little bit of time to see if you have any questions. Otherwise, I'll end it shortly. In this tutorial, we'll import new code for the Sicilian. There's a separate GitHub repository for the tutorial this week. Like every week, there's a new GitHub repository. So make sure you're on the one for tutorial 3. It's going to be the same code in tutorial 3 as last tutorial. But we're going to be doing something a bit different with it this time. All right. Adios, amigos. Have a great remainder of your thing, and I encourage you to come to the tutorial if you guys have time. All right. Oh, where's my mouse?